So what I'd like you to do for the first couple of minutes is I'd like you to make sure that you identify the amplitude, the period, the phase shift, the vertical shift, and the maximum and minimum of each of the functions that you see in this chart here. Let's start with the amplitude. Just identify, remember, all equations look like this. Y is equal to A. Trig function, B, x minus, let's go x minus C plus the D value, where A is the amplitude, B deals with or has something to do with the stretch and compression of the period, and C represents the phase shift left and right, and D represents the up and down motion of our graph. Remember, with our periods, our period is equal to 360 over B, which also means that B is equal to 360 over the period. So the amplitude for each of these. So for the first one, the amplitude is 3. Next one is 2. Next is -4. The next, we have to identify something. Basically, when we talk about amplitude, the amplitude is always just the pure number, no negative or positive signs. So in this case, the amplitude is not actually -4, it's actually +4. For the next one, our amplitude is 0.5. And if you take a look at this last one, we have a -1 again. So our amplitude is actually going to be just 1, strictly 1. Now, dealing with the period, just like we talked about before, we said the period was equal to 360 divided by whatever B value was sitting with the X in each bracket. Now, for the first one, the period is 360 because there is no B value. Essentially, there is a 1 sitting in front of the X. So 360 divided by 1 gives us 360. Now we're going to have 360 divided by 3 for the next one. If you take a look here, with the 3 sitting on the X, we take 360 divided by 3 to get 120 degrees. For the next graph, there is no B value sitting outside of this bracket that represents the phase shift. If there was a B value sitting right here, we would have had some either stretch or compression of the period. So in this case now, 360 divided by 1 just gives us 360 again. Now for this next graph, notice the B value is 2. So we're going to take 360 and divide by 2 to get 180. For the next graph here, notice B is 0.5. 360 divided by 0.5 basically turns it into 720 degrees for the period of each one of these graphs. So now what we'll do is we'll take a look at the phase shift. The phase shift deals with how far, either left or right, X is shifted. Now, just like before when we were looking at our original graph, the -C tells us whether it's moving to the left or to the right. If we have X minus 50, it means we're moving to the right 50. If we had X plus 50, it means we're moving to the left 50. Now, for this graph, notice there is nothing that is with X in a bracket there, so the phase shift, there is none. For the next graph, 3X is in there, and guess what? There is no phase shift again. Now, when we have X minus 90 inside a bracket, it either means it's going left or right. In this case, we are actually moving right 90 degrees because it's minus. Think opposite world. It's opposite to what we expect. Now, for for the next bracket, we have 2x. There is no x minus 90 or anything, so now there is no phase shift. For this next graph here, notice we have x minus 60. So just like we expected before, it's opposite world. So normally we would, so now basically we've got negative 60, which means we're actually moving right 60 degrees. As for vertical shifts, what we're going to do is we're actually going to focus on this last portion of the graph here. Each one of these equations has some number that is related to it. So I'm actually going to always say, if I say negative 3, if I say positive 1, this means our graph moves up 1. Now, for the next graph, take a look at it. We have a negative 2 at the end of our graph. So this means, so a negative 2 really means we're actually going down 2 units. Now you'll see why I use these numbers here to kind of tell me what's actually happening. Now for the next one we have a plus 3, which means it's going up. We have a plus 2 for the next one and a minus 4 for its vertical shift. Now this one means it's moving up. This one means it's moving up 2 units as well. And this last one means it's moving down 2 units. Key idea is to recognize that the plus tells us it's moving up a unit and the minus means it's moving down. We're also going to tie these numbers in nicely with our calculators. So in order to get the maximum, right, I want you to think of what's happening. You actually have a graph. So I'm actually going to draw a little graph here. So imagine, here's my graph, and all I've done is I've moved my axis, my vertical shift, my center line, my axis of my graph. I've moved it up. So imagine I've moved it up to 2. So that's my vertical shift of 2. Now, if I have an amplitude of 3, it means that my graph goes up to a max of not 2, but I go 2 plus 3 to give us 5. So basically what we're going to do is we're just going to add positive 1 and positive 3 from each of these 2 columns that we have here for the vertical shift and the amplitude. By doing so, we have 1 plus 3, which will give us 4. Our next graph, we have a minus 2 and a positive 2. Minus 2 plus 2 gives us 0. For our maximum in this case. Now, remember, we shifted up 3 and we have just positive 3 here. So now what we're going to do is we're going to add positive 3 and positive 4 to give us a value of 7. Our next one is up 2. So we have 2 plus 0.5, which gives us 2.5. Our next graph here, we have negative 4 and positive 1. Negative 4 and positive 1 gives us negative 3 for our maximum. Now, let's talk about the minimums. When we have a minimum, I'm actually going to draw this in black in my little graph. I want you to think about what happens. We have, as usual, our vertical shift. And now our vertical shift is combined with our amplitude. Now our amplitude, instead of going up 3 like we did before when we were doing our max, this time we're going to go down 3. So for the vertical shift of the first graph, we have 1 plus 3 to give us a maximum of 4. So now what we're going to do is we're going to take the number 1 and we're going to subtract the number 3 from it to get a value of negative 2. So 1 minus 3 gives us negative 2. Now, our next graph has a negative 2. A negative 2 minus 2 will give us negative 4. Our next graph has positive 3. Positive 3 minus 4 will give us minus 1 for our minimum. For our next graph, we have our vertical shift being 2. And now what we're going to do is we're going to subtract our 0.5 amplitude, and that will give us 1.5. So 2 minus 0.5 gives us 1.5. Now for our final graph, we have -4, and we've moved down 1. -4 minus 1 will give us -5 as our minimum. So let's talk about the key points of these summaries of each of these equations that we have here. For the amplitude, let's focus on what that means. The amplitude is literally the max minus the min divided by 2. Let's put a bracket around that so we kind of remember. All right, now we also have our vertical shift. Our vertical shift is just the average of the max and the min. And that is always what we understand. It's the max plus the min divided by 2. So you'll see questions where I say the maximum height of the tide is this, and the minimum height of the tide is this. That will tell us our vertical shift, because we'll add the maximum and the minimum to find the vertical shift of any equation. Now, for any new period, just like we said, the period P was equal to 360 divided by P, divided by the B value. You know what? I don't really like how I surrounded my work here. What we're going to do is we're going to just make sure that we put brackets around the basic information. All right, now, basically what you need to remember, we're just summarizing this. The new period is always 360 divided by B. Or if I was trying to find the B value, you basically do 360 divided by the new period, or I always call it P. So let's continue on with the lesson. Now, basically given the features of a sketch, I can actually take the information that I have and I can go back and figure out some information. So now let's go and take a look at this information that we have in this last chart. Notice the max and the min. The max and the min in the first graph is 6 and minus 2. When I try to find the amplitude, I have to take the max and subtract the min and then divide by 2. 6 minus -2 is 8 divided by 2, which gives us an amplitude of 4. The vertical shift is the average of these two. So 6 plus -2 is 4 divided by 2, which gives us, what is it? That's right, it's 2. So for this last graph, after I show you how to do this, this will be great. Now, if you take a look at this final equation here, you notice how we have a period of 720. We need to find the B value, because eventually what we're going to do is we're going to place an equation in here that represents all this information. So right now, we know that our period is 720. So technically what we're doing is we're going to find the B value. So the B value is always 360 divided by P, right? Because remember, we said that earlier. That's what we were talking about right here. That's what we were talking about right here. So 360 divided by P is equal to 360 divided by 720, which is equal to, when we simplify, is 0.5. So basically that's what our b value is. So if we were actually going to write up an equation for this, notice the amplitude is 4, so we'd write y is equal to 4 and now our period was 720, and that's why we went and calculated the b value for this graph. So now remember, our basic equation always looks like this. Y is equal to A trig B x minus C plus D. So here's what we're going to do. So now we know what our b value is. We're going to go and write the b value in. So our b value is going to be 0.5, which is right here. And now that we've got the 0.5, we have to follow what we were doing. So we've got a b. The next thing that we're going to do is we're going to write x in a bracket minus, now this says it's plus 180. Now we have to remember, we're moving to the right, we're moving to the left 180, which really means this is a plus 180 degrees. And now we add a second bracket, and then we say its vertical shift is plus, notice it's 2. So really we're saying it's really plus 2, which means it moves up 2, which means our outside part is plus 2. And we have our equation. What I'd like you to do now is I'd like you to take a look at this next equation that we have here, and I'd like you to come up with your own solution. And I'll show you what your solution is in a minute. Pause the video and then take a look at what your solution is. Okay, so right now we have a maximum and a minimum of -3. A maximum of 1, minimum of -3. So if I want to calculate my amplitude is the max minus the min divided by 2. So here's what we're going to do. So max minus the min, so 1 minus -3 is going to be 4 divided by 2, which is just 2. Oh, that was easy. So now let's take a look at our vertical shift. Our vertical shift is just the addition of these two and divide by 2. 1 minus 3. 1 plus -3 is -2 divided by 2, which gives us -1. So remember, just like before, the plus 2 really meant it went up 2, and the -1 meant it went down 1. Now, let's go and take all this information that we have here and write it into our equation. We always must remember that our equation, our basic equation, looks like this. So now, here we go. So, for the amplitude, we're going to put 2 for cosine. Then what we're going to do is we're going to, oh my goodness, calculate our b value. Oh no, we haven't calculated our b value. The b value for our equation is going to be 360 divided by the period, which is 360 in this case divided by 120. 120 degrees, so that's going to be 3 essentially. So now we go back into our equation and we know that now our b value is 3. We put our bracket x. Now, because it's moving right 90, it's opposite. So we're going to go minus 90 degrees. And now, is it -2 or +2? It's actually -1 because of our equation that we have here. And that is our answer for this first slide of 3. Taking a look at this graph. If you take a look at this graph, some of the things that I like to do is I actually like to draw my little arrows or my little lines to kind of make sure that I can see where the crest of my graph is and the trough of my graph is. Some of you would call this the top and the bottom of the graph. That is okay. We're not looking to be too technical. And we know that this middle part represents our vertical shift. In this case, our vertical shift is 0. So essentially, we're going up 1 and down 1. So our amplitude is essentially 1. But we already know that we have a calculation for amplitude. Let's do that quickly to make sure. We assume that it's 1, but really, we're going to check it. So it's always the max minus the min divided by 2. The max in this case is 1 minus, well, negative 1 divided by 2, which is just the max minus min. Yeah, it's just 1. Perfect. We got our right answer for our amplitude. Now, for the vertical shift of this graph, we have to take the max plus the min divided by 2, which is 1 plus negative 1 divided by 2, which gives us 0. So our vertical shift is 0, just like we expected on our graph. A lot of the times you can eyeball it from the graph, but sometimes you got to do the calculation. Now, as for the period, in order to figure out what the period is, all we have to do, I'm going to write this in red, is we figure out exactly how far it takes for one repetition of the graph. In this case, all we have to do is subtract the two different endpoints of the graph. In this case, on the x-axis, its maximum number is 270, and we're going to subtract 90 to get the period. So our period in this case is 180 degrees. Perfect. Now, let's talk about the rest of this graph. Based on what we see here, this graph has shifted a certain number. Notice the graph starts at the 0 marker, the center, the vertical shift, and it goes up and below. It starts up and then goes below our axis. Now, based on that, this looks like a sine graph. Because sine starts at 0 and ends at 0, or starts on the axis and ends on the axis. So, if you look at this, the phase shift is how far left we have moved. So let me just write this. So this part here in green, the distance, so we have moved left 90 degrees in order to start our graph. The phase shift is how far left or right we moved the base graph. In this case, our phase shift is going to be right 90 degrees for our graph. So, based on all the information that we have an amplitude of 1, a vertical shift of 0, and a period of 180 degrees. I think what we're going to do next is we're going to actually see if we can find a way to represent this graph. We're going to represent, children. So, if I wanted to create an equation for the graph, this is what we'd do. We'd write our general graph. We'd write y is equal to a sine, because we thought it was the sine graph, b x minus c plus d. So what we're going to do is we're just going to substitute all the information we need. So in this case, we'd write y is equal to, well, the amplitude is 1, so we're going to run 1 sine of, well, the b value. I don't know what the b value is. Let's calculate that. The b value is equal to 360 divided by the period, which is 360 divided by 180 because we figured that out earlier right here. So that means our b value is actually 2. So let's write that in. So our b value is 2. And then remember, it's x. Now, is it minus 90 or plus 90? Remember, this has to be opposite world. Because we have moved it to the right 90, it's going to be minus 90 degrees in the bracket here. And then we go plus, what was the vertical shift? If we take a look at the vertical shift, we notice that we identified it to be 0 when we did our calculations. So we can either put nothing there or we just put plus 0 for our equation. So our equation based on the graph is actually 1 sine bracket 2 bracket x minus 90 degrees bracket plus 0. And this graph is this equation, this graph that we have here is represented accurately by all our calculations that we just did. For this graph, we have to identify various things. We have to identify the amplitude. So let's write that out. Here is our amplitude. Let's calculate it. Our amplitude is equal to, well, let's look at this. This is 1, 2, and 3. This is -1, -2, and -3. So our amplitude is the max minus the min divided by 2, which is going to be 3 minus -3 divided by 2, which gives us 3. The vertical shift, let's take a look at this graph. So the vertical shift, notice our maximum and our minimum are at 3. So we're going to do this again. So we're going to go the max. So remember, the vertical shift is just the average. So we're just going to add them. The max plus the min divided by 2, which gives us 3 plus -3, which gives us, divided by 2 gives us 0. That's our vertical shift. So that's it. Our vertical shift is equal to 0. We've got our vertical shift equal to 0. We've got our vertical shift is equal to 0. We have our amplitude is equal to 3. And now what's left is we need to identify the period. In this case, the period, the first repeating value of this graph, goes from 270 and starts at 90. So 90 minus 270 is, so that's our period. So our period is equal to 270 minus 90, which is equal to 180 degrees. So that's our period. Let's call that P. We'll put a box around that. So some of the things that we always need for our basic equations, let's make sure we write that out. So our basic equation is y is equal to a trig of b bracket, I screwed that up, b bracket x minus c plus d. So here's what we're going to do. Once we have our period, one of the things that we're missing, we have the amplitude, which is A. We have the B value, which Oh my gosh, we're missing the b value. Let's calculate that. The b value is equal to 360 divided by the period, which equals to 360 over 180. So that means our b value is actually equal to 2. So now what we need to do is we need to identify 3 different starting points on our graph. So here's what we're going to do. For graph 1, we're going to identify this point here, which is our starting point. So this is our starting point. Now, for the first graph, if I started this at my starting point, and my second graph I started this as my starting point, and my third graph I started this as my starting point. So this is graph 2, and this is graph 3. So we have 3 possibilities. Now, you know that for any graph that starts, if my axis is 0 and it starts above the x-axis, it looks like cosine, doesn't it? So for our first equation, we're going to write, for equation 1, we're going to write y equals, and we're going to leave a little space for the amplitude, cosine, just like before when we were doing our first practice problems, where we identified certain things. So now, we take a look at our amplitude. Our amplitude is 3. And then, we need to also identify the b value of our equation. We notice we found that it to be b. So here's what we'll do. We'll actually go and write this in, b. But no, we're not going to do that. Where instead of writing b, we're going to write in the value of 2 inside our bracket. So we got a 2 here. And then what we have our 2, that is our b value. So now we have to put a bracket. Now we take a look at our original graph. Remember, we're looking at this point here. And notice there is no phase shift for cosine. So what we can do is we're just going to write, well, we're going to use x as our variable in here because we identified that on our graph. Sometimes you might have theta, sometimes you might have x. So we write x. Now, is there a phase shift? If there isn't, we just don't put anything in there because x minus 0 is still just x, is it not? And now we have a vertical shift, which we've identified to be 0. So all we have to do is just add 0. Boom. For graph position number 2, we notice it starts below the axis and ends below the axis. So that immediately tells us that this is an upside down cosine graph. Now, in order to identify a cosine graph when we're creating our equations, we write y is equal to negative, and then we'll write 3 because the amplitude is still 3 cosine, and we still keep our b value just like before. The only thing that changes, really, is going to be what goes inside this bracket that I'm creating here. So we're still going to have x. Now, what we have to do is we have to look at how far to the right of the initial position where we started it has moved. We have moved exactly 90 degrees to the right. So remember, with opposite world, 90 degrees to the right means we have negative 90 in the brackets. Our vertical shift is still 0. And we're done. Now, for the last graph, we've got position 3. So at position 3, notice it starts on the axis and ends on the axis. So this kind of reminds me of a sine function. Actually, it is a sine function. Let's not be kidding. So we're still going to use exactly what we did before. So we got y is equal to, now, if you look at this graph, because it starts at 0 and ends at 0, but goes above and then below, it hasn't changed the original sine function. So in this case, we don't have a negative sign that goes in front of our amplitude. So we got positive 3. Now remember, I told you we're going to use sine to represent position 3 on our graph, where it starts. So now all we have to do, we're still going to use the same b value. Now the only thing that changes is what goes in this bracket. So what we have to do is we have to look for the starting point along the x-axis. And in this case, it starts right here, which is at 135 degrees to the right of the initial position, which is right here. So all we have to do now is we have to write up our answer. So we've moved to the right 135. Remember, opposite world. So we got x minus 135. And then our vertical shift is still plus 0. Now let's continue on to the next problem that I handed out for you. So let's move this down. So we're going to apply the same techniques again. What I want you to do is I want you to try this on your own. Try to compute the maximum and the minimum. Identify the vertical shift. And then I want you to tell me the horizontal shift. Identify 3 key points that we're going to use for our graph. And if you get a chance, once you find your vertical shift, draw it on the graph. And I'll show you what it is. So pause the video. And you do that, and then we'll take a look at the amplitude, the vertical shift, and the phase shift in 3 different key points. So just like before, we've identified the maximum and the minimum. We calculated our max and min, did our calculation, and got a value of 2. So now that we've calculated our max, we just max plus min divided by 2, we get an answer of 1. What you must do in order to make your life easier, kind of do what I do. I take my time and I say, once I've figured out my vertical shift, I actually draw it on the graph just to make sense. So this is my vertical shift and it's going to be 1. So from here I check, oh look at that. I check the distance here and I notice it's 2, and I also notice down here it's only shifted down 2 as well. So we got our amplitude correct. We also have our vertical shift correct because of that symmetry around this axis point. Now we need to identify 3 key points. So I'm going to try two new points for you to work on. I'm going to work on this one, I'm going to work on this point, and I'm going to work on this point here. We're going to call this equation 1, this equation 2, and this equation 3. So we still have to calculate our period. I'll do that right now. By calculating our period, which is identified by these two points, it starts here and ends here. We notice that our period is 180 degrees because 180 minus 0 gives 180. So that's our period. The next part is to calculate our b value, which is always 360 over p, and we get b is equal to 2. So now what we're going to do, I look at this graph. Notice it starts up and ends, and it starts at the top, goes below, and then comes back up. This represents a cosine. So we're going to write y is equal to, for question number 1, our amplitude is 2, so we put in cosine, 2 cosine, and then we identify our b value. Our b value, we said, was 2. So now, do we have a phase shift? If we look at this, it starts at 0. Guess what? No phase shift, so we just write x, nothing else, and our vertical shift is 1, so we add 1 to our final calculation. Pause the video here, try position 2, and then I'll tell you what the answer is. For this next problem 2, we identify we identify that we've got y is equal to 2, but we need to know what graph this is. So if you look at this graph, if I continued on from this, it kind of looks like a sine function, but it's a sine function that's upside down. So this is no longer supposed to be a 2. This still must change. The amplitude is no longer 2, it's -2. So we've essentially flipped it because it starts at 0 but starts down instead of starting up for sine, like we would normally expect. So now that is our amplitude, our A value. So now we have to identify the type of graph. We're going to say that this is a sine graph. Our B value is still 2. Now we have to figure out our phase shift. Our phase shift is identified by how far over from the basic starting position we've gone to the start of our graph. And in this case, we started 45 degrees to the right. So we're going to write x minus 45 degrees. And then our vertical shift is +1. Pause the video and see if you can do position 3. For position 3, I'm going to write this in black. For position 3, if I look at this graph, it kind of looks like it starts below the x-axis and continues on. So eventually it's going to look, oh my goodness, it's a upside down cosine graph. So we're going to start by writing position 3 is y is equal to, well, before, if it's a normal position where it starts above the line, then we would leave it as +2. But because it's below the -9, we have to write this as -2. And because it's position 3 and it's a cosine graph but upside down, we're going to use cosine for the function. Our B value is still 2. And now we have to identify the phase shift. We look at the graph and we see where the phase shift is. We start from the edge where it normally would have started, which would have been up here, and we figure out exactly how far it's moved over. In this case, it's actually moved to the right 90. So we're going to write x minus 90 in the bracket. And we still have our vertical shift of being +1. And there you have it, kids. No difficulties. All right? So I expect you to be able to do something like this on a test. The analysis of the graph to figure out how far you have to go and subtract, to figure out the vertical shift. You will most likely have to make sure